This is a remix based on the excellent Mini-Skidi design by John, who goes by the handle ProfessorBoots. We'll take a look at his original design. It can be found on Instructables, and it's very inexpensive, easy to build. It's remote controlled by either your phone or an iPad, which is nice. You don't need a separate controller for it. I certainly encourage you to build kits if you want the whole kit of electronics and parts. John sells both that kit or just the electronics. He's done a tremendous job in designing this, and he's provided everything open source, even the Gerber files for the PCB, the software, all step files, so it's very easy to change or tweak anything that you might want here. And you'll see the original design. It uses a TPU for the belts. You don't need to buy belts, and TPU for the tires, which work really well on a rough surface. I wanted to have a little better grip, and so I wanted to use some very soft silicon or rubber tires. So this remix is based around that modification. Now, this tire is very cheap and available from AliExpress for very little money. It's about 43 millimeters, so it's about 3 millimeters larger, 3 or 4, pretty close to the same width. And it works on the same hub, or the original hub from the design by John. Or you can make a unique hub that will fit this tire a little more precisely, and that's what I've done. So in my remix, you'll see a new hub there. And you'll notice that I've also tightened up the tolerance here. When this hits the drive axle, there's quite a bit of play with the original hub. This one's just a little bit tighter. And I'll go over all the other changes I've made along the way. Now, I'll show you why I wanted the a little better traction. I'll show you a little bit about the performance of my first Mini-Skidi with this remix that I've done. So here it is with the rubber tires. I'm just showing going over and the type of traction you'll get with it. Now, TPU tires are great. They're just very slick on hard, smooth surfaces. So I tested this just going up a scale here. And you find this pretty challenging with TPU on a very smooth surface. I also had another problem, and probably because my printer's a little different and I purchased my own parts. I had a bit of a belt issue that you can see here, in that because I didn't have everything quite straight and the belts tended to wander off, and they didn't sit in this groove really well here. So I did have a solution, and one solution that worked pretty well was using this to hold the belt, but you'll notice here that it's still not meshing quite perfectly with the cog, and it rides a little high here. So what I wanted to do was look at a little better solution. So I made a bunch of modifications, and one of the first things I did was to go with a universal pulley or drive shaft. You only need, if you look at my remix, I use this one part for all four wheels, so they're now universal. I brought out this D, was a little shallower, brought out for just a little bit better grip. But the biggest change I made were these faces here. I offset back about 2 millimeters on each side, so the groove is wider and the belt can more easily slip in the groove. I also made on all these universal pulleys I made this 8.9 millimeter, which is going into a 9.2 millimeter hole. So there's only 0.3 millimeter tolerance, and it'll fit much more snug. There's a clip that will go on here to hold this against the wall, and the original clip's 1 millimeter. I found for my printer 1.4 millimeter held this much better and straighter. Now, in order to get a nice smooth surface on the top, because this is printed on the bottom, I just painted on 4 little strips of support. So there's just four little towers of support around here. And I peeled those off, and that gave me a pretty good cutout here. Now, I've also provided the original pulleys that John used with this wider belt cutout, so you can try that if you're having problems with your belt and you want to use all the same original parts. Now, I made quite a few changes to the main housing. These circles on one side here, this is where the motor goes, this is where the no motor pulley goes, but these were different sizes. I made them all the same size hole, 9.2 millimeters, so I could use a universal pulley. This is where the fender goes. I made this a little wider just for better support. Up here was fairly thin and very easy to break. I beefed up this area, and I designed this for a 3 millimeter by 10 flathead or countersink type of bolt. Most people who build RC cars and that have a lot of metric screws around, so I just found this a convenient size to use here. Now, one of the things you'll notice here is that there's a little peak on top of the circles. And this is actually a design technique. If you just make a circle, when the circle gets printed, especially vertically, this top here will flatten out. And so your circle will become undersized, and it's hard to get a better circle. So if you make a little peak on the top here, that circle stays more true. Now, your shaft won't make connection, but only at this very small little area here. So this allows you to have a much snugger and more accurate connection to a shaft that's rotating in this type of circle. And I did these just on the 2 small ones. It wasn't necessary for the larger ones. That's just a design technique for 3D printing that can help you if you're doing vertical circles. Inside the housing, I added some supports on the bottom to hold the track in place so it didn't wander. So this was like a track guide. To hold the motors down, this was a little deeper than this, so I just cut this back and made the depths the same. And I also made this wider. The top was wider. It was always wide at the same width at the bottom, but on the top where it bolted the motor down, I just made this a full width so it would hold the motor a little better. These small holes here were designed for, I think, 2.6 by 8 screws, which have a self-cutting thread, which are very good, and they're better than a machine screw, but a lot of us have 2 millimeter machine screws, so I made this a little smaller. I went down from 2 millimeters to 1.7 millimeters, so you could still use the 2 by 6 by 8, but you can also now use a 2 millimeter M2 screw on all these holes here, if you wish. I also added a PCB support. You'll notice there was a support here on the wall, and when you printed it, you required some support to hold that up. I took that out and opted for a support here that held the printed circuit board a little better. You'll see that in a second. So we'll look at the belt fix that we did here. So this is the new housing. You'll see the guides holding the belt in place, and you'll see the printed circuit board support holds that well. You'll also notice that the belt meshes better in these little wider cogs here. They're not riding off, which is fairly nice. And they're only drawing about 120 maybe milliamps at the most at 5 volts. So far, I've only built one. So far, that solution worked really well. Now the fender has to be a little bigger. Those wheels are a little bigger, so unfortunately if you use those wheels you have to use custom fenders. I just provided one, and you would just mirror this to provide the fender for the other side. Now, because the wheels are bigger, I had to extend this, and basically I just designed this from scratch based on John's design. It's 3.5 millimeter longer. The letters are a little larger and at a little different angle. Now what I did was I printed them in two color. This is the face that goes down in the bed of the printer, and I printed so many millimeters until the backing came in. Then I printed 3 layers of a different color backing, and you'll see that effect in a second. For the left arm, you'll notice the left arm looks identical to the right arm. Well, I duplicated, I made an exact copy just to save myself some design work, but I had to reverse image the lettering here because when you bring this into your slicer, you're going to mirror it in the Y direction so that this right arm becomes a left arm and the lettering will be the way it should be. So just remember, when you get this part, you have to mirror it in your slicer. A couple other changes I made to the cover. I closed the original cover and I couldn't get it back open. It really grabbed tight. So I made a little handle here. I also broke these from some tipping over and misuse. I made these a little thicker here. Because this is designed for 3 millimeter machine screw, I beefed up this area, and this is designed to take a 2.5 millimeter. It's 2.5 millimeters so that a 3 millimeter can self-thread in it. I backed off a little bit here. Now this is printed on its side, and when it's printed on its side it needs a little support here, really just around the hole. You can paint on support. And this tip here is actually back from this face, so this tip needs support here. So those are the 2 areas that need support, the rest is fine. This was the cage, and some of the changes I made here is I found that without support, this edge at the top was pretty rough. Prints fine with support. I just changed it to 45 degrees so I wouldn't need support. I beefed up this area, and this is now a 3 millimeter hole, so it'll take that 3 millimeter screw. I have a larger battery. I couldn't find those Tattoo 300 milliamp hour batteries easily, and those are excellent batteries and they fit really well. I had to use a larger battery. So you can use a battery in here that's 55 times 30 times 17 millimeters, as big as that, which is just a little bit bigger than a 9-volt battery. So mine is a 2S 1200 milliamp hour, and it lasts quite long. I think it would last almost up to an hour. But to hold the battery in, I made a part here that basically wedges into these little squares on either side, and it holds the battery in between here. It just sort of comes down on it, and I'll show you this in a picture. But first I'll just show you these 2 edges. So this was this 45 degree without support. If I tried to do the original cage without support, it became pretty rough. Now that'd be fine with support. I just redesigned it so it didn't need support. So here's my unfinished Mini-Skidi with all these changes, and you can see the bigger tires here. Now because this is larger, this is pretty close here, but it doesn't touch. And you'll notice this 2 color lettering here, which makes it stand out. Now this was just done with 2 layers behind. With 3 layers it's even a bit better for being solid in a second color. From a top view, right in here you can see the little black pegs that will come down and they'll hold the battery. This is the cover here, and this is the bucket. Now this is just a mock-up right now. I don't have all the electronics for it. So that's just an explanation of this remix, and you may find some parts of that will help you if you're having any problems, or if you want to use the rubber tire design.